Hey guys, welcome back. Day 29, second part. Reactions of the main group elements. Remember, the main group elements are the tall ones. We had the periodic table. Right? Over here and over here, right? Those are the main group elements. Let's highlights better. I like highlight better. So these ones and these ones. We're not worried about the transition metals or the intertransition metals, lanthanides and actinides. We're not worried about those right now. Main group. Okay, so now if you are in the members of a group tend to exhibit similar chemical behaviors and physical properties, right? Because of the same electron configurations. So, right, things want to be isoelectronic with noble gases, so they're going to react to be like a noble gas. The exception is, all right, are two. One, period two, because they're so small, tend to be a little bit different than the rest of the periodic table, right, than periods 3 through 7. And hydrogen. Hydrogen is unique. Right? Hydrogen is 1s1, one electron. So you get a lot of H plus, which is just a proton. Right? Proton. Right? And then you can also get H minus, which is hydride. And there are a lot of hydride reactions that are very important. A lot of metal hydrides, sodium hydride with water going to sodium hydroxide and H2, and that's actually a pretty violent reaction, right? The most important reaction for hydrogen, of course, is 2H2O, or H2 gas, plus O2 gas, going to 2H2O liquid. If you could get the sunlight, and the sunlight to make this reaction, actually I would probably have the sun on the other side, right? If I could make the reaction, if sun to break this up into hydrogen and oxygen, we'd have unlimited energy, right? We need to be able to split water. That would be great, right? And then when you burn hydrogen, the only product is water, which is fantastic. So it would be good. That would be fantastic if we could do that. Right now we can't. Maybe we could in the future, I don't know. Good problem to solve. All right, group 1 and group 2. These are the active metals. All right? And those active metals, group 1 and group 2, they like to react with water. Like, so active metals means they're going to react. Okay? Now, for example, group 1, lithium, which is a solid, will react with water, and it makes the lithium hydroxide and H2 gas. And it produces heat, light. It's kind of neat. Now, sometimes these react with oxygen as well. So lithium plus O2 goes to lithium oxide. And you need a 4 there and a 4 there. However, potassium plus oxygen goes to potassium superoxide. And that's because the superoxide is actually more stable with potassium. Lithium, I think, is too small for it to be stable. Right? So some of the heavier group 1s with oxygen can make the peroxides. Right? And so all the alkali metals this should be tend to be highly reactive toward oxygen, water, and acids. Group 2, same thing. Now, with group 2, all right, beryllium does not react with water, and Mg needs warm water. Very slow. but they make, right, they're typically less reactive than group 1, right, but they also do produce metal hydroxides and hydrogen gas, all right, and so that's, and you see how the metal can be any of them. That's how it's going to work out, okay, and typically you need 2 here, you need a 2 here too, right, so this is a 2, this is a 2, and this is a 2, and here, these, that's a 2. All right. Moving on. Some group 13, that's aluminum, right? Aluminum will react with oxygen gas to make an aluminum oxide. This happens with all your aluminum. All your aluminum you see aluminum oxide, because if you scratch it, I'm not saying to do this, but if you scratch it, you'll actually see aluminum, which is a slightly different color than the aluminum oxide. But that aluminum oxide makes a nice protective layer around the aluminum. And so that's why we can use like aluminum boats, aluminum rims, use aluminum for stuff, and it's okay. Aluminum also reacts with acid. That is a thing as well. All right, and so to balance these, right, for example, I would start with the aluminum oxide. I got 2 and 3, so I need to put a 2 there and a 3 there to make that work out, which ends up being a 4 here. For here, I would just, let's see, yeah, I would just need to put a 2 there. Right, but the thing is, right, we wouldn't balance this, because if you take electrochemistry, you'd actually have a 2, a 6, a 2, and a 3. You would need that, and that would make sense later on. All right, and so aluminum does that. Other main groups, 14, 15, 16, they're totally different sometimes. It just depends. So you got tin, lead. Tin and lead tend to be +2, but not always, right? Carbon is a little bit different, and silicone is different altogether as well. And your book doesn't go into them much, all right? Although carbon dioxide is more stable than carbon monoxide, and it goes into a little bit of stuff. Group 15, a lot of times these things will make acids, these non-metal oxides like dinitrogen pentaoxide and tetraphosphorus decaoxide. They'll make nitric and phosphoric acids. Sulfur makes with water, typically makes sulfuric acid. Halogens react with hydrogen to make the hydrogen halide, right? And typically group 18 is stable, right? Why? It's S2P6, right? Whatever those coefficients are. Now, Kr can react with fluorine, and xenon can react with F and O. But helium, neon, argon, no reactions on Earth. All right, so those are some of the properties and some of the reactions that happen with oxygen and water and whatnot for the main groups. So let's practice some balancing, and then we'll wrap up day 29. So if you remember, propane was this one. We did this one a while ago. C3H8 plus O2 goes to CO2 and H2O. And if we were to balance this, all right, 3 carbons on the left, 3 carbons on the right. 8 hydrogen, 8 hydrogen. So then we have 3 times 2 is 6, plus 4 is 10. 10 divided by 2, 5 oxygen. So 1 mole of propane, which is here, all right, requires how many moles of oxygen? 5. Produces how many moles of CO2? 3. Also produces 4 moles of water. All right, so this is what we're going to. What mass of carbon dioxide is produced from that many grams of propane? Okay, that's an amount, right? This is the amount. And so I'm going to take my 110 grams, C3H8, got my amount. And the first ratio is grams to moles. 1 mole of C3H8. And again, now you'll need your periodic table just like before. You always need it because carbon weighs 12.01 times 3 plus 8, right? So 36 and 8, 44. So it's 44.11 grams of C3H8. Then we have moles of C3H8 on the bottom. And we want moles of CO2. And that mole ratio is from the balanced chemical equation. 1 and 3. So the 1 is there, and 3 is there. But we want mass, right? We want masses in grams. So that means we got to go back. 1 mole of CO2 is 44.01 grams of CO2. Again, you got 16 plus 16 plus 12. 44. All right. And if we do this, if you look, grams cancel. Moles cancel. And let's use blue. Use blue. Moles cancel. And you're left with grams of CO2, which is what you want. And if you do this math, I think you get 330. All right. Now, the next question is not mass. It asks how many moles of H2O2 are produced in this case. So, in this case, is still the 110 grams of propane. So, it's going to look very similar. 110 grams of propane, right? Same thing to start. And we're going to move that back into 44.11 grams of C3H8 is 1 mole of C3H8. But this is the next one, moles of C3H8 on the bottom. But now we want moles of H2O. And the moles are different. The bottom one's still 1, but now it's 4 for water. And that's what we want. We want moles, so we're done. All right? And if you do that math, that becomes 10 moles of H2O produced. All right, 10 moles. Now you times that by 8, it's 180 grams, because that's what the molar mass is, but 10 moles of water. Now, what mass of oxygen is required? Again, you're going to start with the same thing. 110 grams of C3H8. And again, same old story. 44.01 grams of propane on the bottom. The molar mass propane, right, is 1 mole of C3H8. Then we have moles of C3H8 on the bottom, oxygen on top, moles of O2, mole ratio, 1 and 5. And then we're going to go to grams. 1 mole of O2 is 32 grams O2. If we do that, I think we get 400. So if I could recap this, here is a molar mass, a mole ratio, and another molar mass. And we start with an amount and an amount. All right? So that's where we are. Now, this is also, 10 moles is also an amount. Okay? And so we're going to start with the amount, use our ratios, right? All of these are ratios. To get to a new amount. All right? Now, a little foreshadowing for later on. What happens if there's not enough oxygen in this case? Well, then not all of the C3H8 will react. All right? That makes sense, doesn't it? Now, hopefully it's in a controlled environment and there's not enough, it's not like there's not enough oxygen in the atmosphere. That'd be really bad. All right, so that is balancing. Now, in the next video, before you even watch it, it's going to be day 30, and you're going to be balancing equations. All right? Balance those without the video if you can, and then watch the video when you need to. All right? And then we're going to go do this stoichiometry in the video after that. Okay, so there's a lot coming. Go ahead and try them. Watch them. Reach out to me if you have questions. Until next time, take care, guys. Have a good one.